hence faster will be the reaction. Third point, on increasing temperature, more molecules become active and hence the rate of reaction increases. Fourth, there always exists an equilibrium between normal and active molecules for a reactant at each temperature. Fifth, active molecules of reactants of a reaction collide to form a transition state of highest energy. Means its energy is more than that of reactants and products both. This transition state is called activated complex. This activated complex is short-lived. It may decompose to form products. The decomposition of activated complex is always a unimolecular process. Let us consider a reaction A plus BC giving products. Then the occurrence of reaction according to Arrhenius theory can be shown by following figure, which is a sort of graph between potential energy or energy of the system versus reaction coordinate or reaction path. In the above figure, E1 is equal to energy of activation for the forward reaction, that is A plus BC giving AB plus C. E2 is equal to energy of activation for the backward reaction, that is AB plus C giving A plus BC. Delta H is equal to heat of reaction or enthalpy change for the overall reaction, A plus BC giving AB plus C. Remember, if E1 is more than E2, then delta H will be positive and reaction will be called an endothermic reaction. On the other hand, if E1 is less than E2, as shown in the above figure, then delta H will be negative and hence the reaction is exothermic reaction. Thus activated complex is a sort of energy barrier for the reaction. Without crossing this barrier, the reaction cannot go ahead. Now we can understand that when 1 or 2 drops of KMnO4 are added to some ice-cold oxalic acid solution, the color of KMnO4 does not disappear for some time. Though KMnO4 is an oxidizing agent, an oxalic acid is reducing. Hence the reaction 16H plus 2MnO4 minus plus 5C2O4 2 minus giving 2Mn2 plus 10CO2 plus 8H2 must take place. But since the temperature 0 degree Celsius is so low that the average energy of reacting molecules itself is very small, and hence the percentage of active molecules possessing energy equal to E or more than E is likely to be further smaller. Hence the reaction is very slow at such a low temperature. Now if we raise the temperature, take warm oxalic acid solution, the color of drops of KMnO4 added disappears quickly. until we reach the end point of the titration. On increasing temperature, more and more molecules qualify to become active because E remains constant, so that collisions of active molecules increase, and that's why the rate of reaction increases.